Here we are at a skateboard park, and you can learn lots of physics at a skateboard park. This is a great simulation from the PHET website. The skateboarder is at rest, hasn't got any velocity, staying still, and is at the bottom of the skateboard park slope. Now, we can give the skateboarder gravitational potential energy just by lifting her up to the top of the slope. And you can see now with the skateboarder at the top of the slope and taking a look at the graphs, you can see that blue column is her potential energy. Just forget about the total column for a moment. The potential energy of the skateboarder can easily be calculated. It's the mass of the skateboarder times the gravitational field strength G times the height the skateboarder is up. Now once the skateboarder starts to move down, that potential energy which the skateboarder has will be transferred into kinetic energy, the energy of movement. And providing there's no friction, the skateboarder will go down through to the bottom of the skateboard park and then up to the top, and should be finishing up at the same height. But take a closer look at the potential energy and how it's transferred into kinetic energy. We'll do it slow to begin with. You can see the kinetic energy now at its maximum, and then we have the potential energy at its maximum. So the potential energy at the top of the slope will be changed into kinetic energy at the bottom, and provided there's no friction to remove some of that energy, then the kinetic energy at the bottom should equal the kinetic energy at the top. We'll do it once more. Watch the graph of potential energy going down, being transferred into kinetic energy, and at the bottom here, all the potential energy is now changed into kinetic energy. So if that skateboarder had a potential energy of say 100 joules at the top, then at the bottom she'll have 100 joules of kinetic energy and no potential energy. And it's the same as the skateboarder rises up the slope. The kinetic energy will be changed into potential energy. So all that kinetic energy will be changed into potential energy, which will take it further up the slope. So here's a girl of mass 50 kilograms starting from rest on a slope of a height of 5 metres in the skateboard park. And what we asked to do is determine the potential energy at point A. Now the little graph there shows you that at that position A, the skateboarding girl has all got potential energy. No other type of energy, just potential energy. And if we look at position B, you can see that all that potential energy has been transferred into kinetic energy. So whatever potential energy you had has now been transferred into kinetic energy at the bottom. So what is the potential energy at the top? Well, we use our formula. EP is going to equal to the mass times gravity times the height. We know the mass of the skateboarder is 50 kilograms times 9.8, the gravitational field strength, times the height which the skateboarder started off from the ground, is going to be 5. So the potential energy, if we work that out in our calculator, is going to be 2,450 joules. So up here we're going to have 2,450 joules of potential energy. Now it asks us to state the kinetic energy at point B. Well, all that potential energy has been transferred into kinetic energy. So the kinetic energy at this position point B will be exactly the same as the potential energy. It will be 2,450 joules. So that will be the kinetic energy at the bottom of the slope. So now we've got the fact that the girl's gravitational potential energy is 2,450 joules at position A. And when she goes down to the bottom, all that gravitational potential energy has been transferred into kinetic energy. And it's going to be the same value, 2,450 joules. Now, if we know the kinetic energy of the skateboarder at position B, then we can find the skateboarder's speed. Because we know that the kinetic energy formula, EK, is going to just simply equal to 1/2 times the mass times v squared. That's the kinetic energy formula. Now, to find the speed from that, we have to do a wee bit of manoeuvring about, so I'll do it step by step and you can practice how we do this. To find v On its own, we first of all got to get rid of that half there. We multiply both sides by 2 to give us 2ek is going to equal to mv squared. To get v squared on its own, we must divide both sides by m, and we have 2ek, 2 times the kinetic energy divided by the mass, is going to equal to v squared. And to get v on its own, finally, we have to take the square root of both sides. So the square root of this expression here, 2 times the kinetic energy divided by the mass, will give you the value of the speed. So if we know the gravitational potential energy at a certain point, then when the skateboard gets down to the bottom, we know that gravitational potential energy has become the kinetic energy. And therefore we can plug the kinetic energy into the formula and find the skateboarder's speed. So let's do that now then. So the kinetic energy will be 2,450 joules, exact same as the potential energy. So V is going to equal to the square root of bracket 2 times this kinetic energy, 2450, divided by the mass, and the mass is going to be 50. And if we do that in a calculator, we end up with the speed of the skateboarder to be about 9.9 meters per second. So that's us found out how to work out the speed of something once we know its potential energy has been transferred into kinetic energy. So just to recap, if we slide up a wee here, the skateboard in its position here, due to her height, has got gravitational potential energy, mgh, to the value of 2,450 joules. Provided there's no friction on the track, then all that potential energy will be transferred into kinetic energy. So at position B, there'll be no potential energy. It's all been transferred into kinetic energy. And if we know the value of the potential energy, we'll know the value of the kinetic energy. And we can use a little formula here that the speed of the skateboarder with a certain amount of kinetic energy is simply found by saying twice the kinetic energy divided by the mass, take the square root, will give you the speed. And that's how we find the speed of something at the bottom of a slope. So here we have a situation where the skateboarder is at the bottom of the slope and she's travelling with a speed of 9 meters per second. So she's got a speed of 9 meters per second and she's heading towards this slope. Now she's going to have kinetic energy because she's got a speed. And we can easily find that kinetic energy, but we know it's going to be simply equal to half times her mass times the speed squared. But as she travels up the slope, that kinetic energy is being transferred into potential energy. She'll be losing her kinetic energy and it'll be transferred into potential energy until she gets to a point where she's got no kinetic energy left to transfer. She comes to a stop and all the energy she's got is now potential energy, and that's at position B. And you can see that from the two graphs. When she's moving at the bottom of the slope, she's got no potential energy, but she's got kinetic energy. When she reaches the maximum height up the slope, she's going to have all potential energy, and because she's stopped moving, she'll have no kinetic energy. So we want to find the height in which this skateboarder is going to stop at on that slope. And to do that, we first of all have got to find out the kinetic energy she had to begin with. And we know that's easily found out. The kinetic energy Ek is going to equal to 1/2 times the mass times the speed squared. So that's going to be 1/2 times the mass of the skateboarder times 70 times the speed squared, which is going to be 9 squared. Don't forget the squared there. And we do that in a calculator, we get a kinetic energy of 2,835 joules. So that's going to be her kinetic energy. So she's going to have 2,835 joules of kinetic energy. Now when she gets to the top of her slope and stops, all that kinetic energy has now been transferred into potential energy. So she's going to have a potential energy of 2,835 joules because the energy which she has, kinetic energy, has been transferred into potential energy. So we know at the top of the slope she's going to have no kinetic energy and she's going to have 2,835 joules of potential energy. So what will be her height? Well, we do know that the equation for the potential energy EP is going to be equal to the mass of the person times G times the h, which is the height above the ground. Now we want to find h in this case, so to find h we have to divide both sides by mg. So we get EP divided by mg, and that's going to give us the height. So really what you're doing to find the height of that skateboarder is really dividing by the weight, because the weight's mg. That's something else to think about. So to find the height this skateboarder stops at, the height h will be equal to her potential energy, which has come from all her kinetic energy, which has got the value of 2835. Divided by bracket the mass of the person, which is going to be, in this case, 70 kilograms. So 70 kilograms times 9.8. So when we do that in the calculator, we end up with a value of height to be about 4.1 meters. So we know that her kinetic energy at this position here is going to take her up to a height of about 4.1 meters. So rehearse having to change the potential energy to the height. The height is equal to the potential energy divided by mg, and we know that mg also equals the weight. So potential energy divided by the weight gives you the height in which the skateboarder rose to. But the most important thing to understand here is this transfer of energy. All her kinetic energy at the bottom, provided there's no friction, will be transferred into potential energy, and that's the value of the potential energy we use to calculate the skateboarder's height up the slope.